As you study parametrics, my friends, the most important application is what are you going to need to do on AP exam day? The content's the same. We're doing parametric equations or vector valued functions, but the terminology might be a little different. They might use distance instead of arc length or something like that on the AP exam. But all that content in your book, it's the same stuff. However, you need to get familiar with the AP questions. So this video is completely dedicated to this question, which came from an old AP exam, but the topic is parametrics. As they do a lot of the times, they use a position, velocity, acceleration situation, but they change it to parametric, meaning we do not have one equation for the position. We have two equations, an x of t and a y of t. So you could get any side-to-side location or any up and down location at time t. What they actually gave us was the x velocity, which is x prime of t or dx dt. And as they often do, again, they told us y prime is not explicitly given. So we do not have an equation for y prime, which just means we're not going to need it. So no big deal. All right, so let's look for stuff that we've been working on in our books, but apply it to this test. Okay, first of all, this is a particle. It's moving from A to B to C to D. So as we talked about when we graphed parametrics, you have a direction, okay? Because as time passes, this thing might be moving left to right or it might be moving right to left. Sometimes it'll go to a point, stop, and then turn around and go right back on the same path. This one's moving from 0 to 9, and this is not necessarily seconds, I don't think, but at time 0, it's over there. At time 9, it's over there. All right. And I think we're ready to start. All right, so at point C, is dy dt positive and is dx dt positive? Give a reason for each answer. Okay, well, what you need to know is what does dy dt mean? Dy dt is the y velocity. And the velocity is just, the speed with the direction. We don't really care about the numbers right here, but what this is saying is dy dt positive. That would mean that y is increasing, that it's moving up. So is the particle moving up and to the right at point C? Well, no, look at the picture. It's moving down and to the left at point C. So our answer for A is no for both. Okay, it's not moving up and right, it's moving down and left. And what we know about down and left, which means so, therefore, all right, so it's not moving up and right, it's moving down and left. Both of those things are negative. So I'm going to kind of write an answer in my words, and then we're going to flip over to the answer key and see what the professionals wrote as their answer. So at point C, dy dt is not positive because y of t is decreasing along the arc BD as t increases. So where I said it's moving down, they said y of t is decreasing. So you might be better off writing what they said, but I think you would get your point with my answer. Dx dt is not positive because x of t is decreasing. In other words, if your x value is decreasing, you're going to the left. All right, there we go. Part 1, 2 points. Got them. Part B. The slope of the curve is undefined at point B. You see that sharp point at B. At what time t is the particle at point B? Excellent question. When does that sharp point happen? So the Calc 1 knowledge here is that sharp points happen when the derivative is undefined. All right? So the derivative is undefined when dy dx, which is equal to dy dt over dx dt, is undefined. Okay, so remember, dy dt and dx dt, those tell us how x and y change, but those don't really have a graphical picture. We don't see dy dt and dx dt. We see dy dx because this is a graph of xy. All right, so it's still the Cartesian xy coordinate plane. So we need, if we're talking about the slope of this particular curve being undefined, we need dy dx. So where is dy dx undefined? Well, fractions are undefined when the denominator is 0. So I need to see, where is dx dt going to be 0? Because regardless of what dy dt is, the only way for a fraction to be 0 is if the bottom is 0. All right, so where does that happen? Well, dx dt, which I need to make 0, is -9 cosine pi t over 6 times sine of pi square root t plus 1 all over 2. Okay? So you should probably organize your notes better than this, but I'm trying to keep the question and the answers on the same page the best I can. All right, so if you have two things multiplied together and you need it to equal 0, then both of those individual parts you need to set equal to 0. Okay, so if -9 cosine pi t over 6 is going to equal 0, then the -9 doesn't mean anything, really. I would divide by -9 and just get rid of it. All right, so now I'm back to unit circle days. Where is cosine equal to 0? And remember, t is going from 0 to 9, and it looks like I'm in the early end of that. So I'm just going to start at 0 and work my way around the unit circle. Cosine is 0 when x is 0, and that's going to happen at the top of the unit circle at pi over 2. So the cosine of pi over 2 equals 0, which means pi t over 6 must equal pi over 2, which means t must equal 3. Okay? If you did the same thing for the sine part, if you took this part right here and set it equal to 0, you're going to get 3 there also. Because think about it, 3 plus 1 is 4, square root is 2, the 2's cancel. Sine of pi equals 0. So time t equals 3, and you could confirm it on the sine part. There are no other locations, no other times where this is going to happen. So on your exam, it'd be a good idea to find 3 with both parts. But right now, we've found the one location, time t equals 3. A lot of times I'll say 3 seconds when I'm talking about parametrics, even though that t does not always mean time. And in this case, it doesn't necessarily mean seconds. But it's okay. Part B, set dx dt equal to 0. Solve and get t equals 3. And it works for both of them. T equals 3 gives you dx dt and dy, it gives you dx dt equals 0 because the sine part and the cosine part are both equal to 0 at that point. They didn't both have to be, but they both were. All right, so there's 4 points we've gotten. Let's move on to part C. The line tangent to the curve at the point x of 8, y of 8 has equation 5/9 minus 2. Find the velocity vector and the speed of the particle at this point. So when they go in and they tell us the tangent line, what they're really just sneaking in there for us is the slope. The slope is 5/9. All right, so now the velocity vector and the speed at this point. The velocity vector, when they ask us for a vector, what you want to give is pointy parentheses, number, number. Then we'll take that and basically square them, add them, and square root like the Pythagorean theorem to get the speed, but let's just focus on the velocity vector first. So part C. Velocity vector at this point, at 8. The x part of the velocity vector is just 8 plugged into dx dt, correct? So all I need to do is find x prime of 8, and then I'm half done with the velocity vector. X prime of 8 is -9 cosine of 8t over 6, which is 8 pi over 6, which is 4 pi over 3, times the sine of, plug in 8, I get 3 pi over 2. Okay, that's just putting in 8 right here and right here. Okay, so that's, remember, this is some more, 3 pi over 2. Some good unit circle stuff. Cosine 4 pi over 3 is -1/2. -9 times -1/2 is 4.5. And the sine of 3 pi over 2, 3 pi over 2 is at the bottom of the unit circle. The sine there is -1. So I get -4.5 for the first part of my velocity vector. But when we go to find y prime of 8, there is no equation for dy dt. So something's missing. This is how they make stuff tricky. However, I do know the slope is 5/9. All right, I know that dy dx, which is equal to dy dt over dx dt, is equal to 5/9. All right, so now that I know x prime or dx dt, and instead of calling it -4.5 so I can deal with fractions, let's call dx dt -9/2, and dy dt is what I'm looking for. And then to solve this equation right here, I'm going to multiply both sides of the equation by -9/2, and I'm going to get canceling 9s and -5/2 or -2.5 as dy dt. So velocity vector, part C, find the velocity vector and the speed. The velocity vector, -4.5, -2.5. And you can put those, excuse me, I said 5 and wrote 9. You could write that as -9/2, -5/2. All right, so now for the speed. The speed is just the two parts of the velocity vector squared, added together, and square rooted. All right, Pythagorean theorem. For the sake of time, I'm going to cheat on that one. There's my -9/2. There's my -5/2. Square those, add them, square root, and you get 5.147 or 5.148. 3 decimal places. Okay, so there we go, part C. Part D, how far apart are the points A and D, the initial and final positions respectively of the particles? So this is classic parametric. How far apart are they? Well, they are both on the same height of 0. So we're only looking at x's. How much has x changed from 0 to 9? So I can think of a couple approaches. I would, well, I guess they're technically the same. I was thinking I don't have x of t, I have x prime. So one way or the other, I'm going to need to integrate x prime to get back to the x level, the position. But I can kind of do that in one swift step. This is going to be, think of it this way. Where does the particle end up? It ends up where it finished minus where it started. All right, how much has its x position changed from 0 to 9? So basically what that all boils down to is the integral from 0 to 9 of x prime. All right, because if you integrate the derivative, you end up with x, which is, so we're going to have x of 9 minus x of 0. A lot of times these questions will say, here's where I was, and then I moved with this velocity for this amount of time, and I've said a lot of times in class, where you end up is where you started plus how much you've changed. Well, this is just the change. How much have you changed? So I need to integrate the x prime, right? X is position. The integral of x from a starting point to a stopping point is change in position. So I'm going to integrate that -9 cosine pi t over x times sine of pi square root sine integrate that from 0 to 9, and I'm going to get my change from 0 to 9. Y, the y portion of this vector, of this parametric, had nothing to do with it because I'm on the same level, which is a height of 0. So the only thing that matters is how much has x changed on this time period. And again, for the sake of time, I would type this into my calculator to integrate it. But here is that, -39.255. When you're doing these parametrics, you do not have to switch your calculator into parametric mode to do this integral. The t is just a variable. It could be any letter that your calculator will type. So I would just type it, just do the normal xy integral. To do that, type it in y equals and use x for your variable. You do not have to switch. A lot of people switch it over and get confused on that. All right, if you want to graph some parametrics, I just noticed that should be a 6. If you want to graph some parametrics, you need to be in parametric mode. But to do the integral function, math 9, integrate, you don't need to be in parametric mode. All right, your calculator is going to do that numerically regardless of what mode you are in. All right, so there is a good solid example of parametrics on the AP exam. You may or may not get one, but there's a pretty good chance this will be one of yours. And if you can get these 9, you're on your way to that 5, young